Today what we're going to talk about is graphing multiple representations. So we're going to talk about interpreting graphs, plotting points on a coordinate plane, and identifying their quadrant, and creating a multiple representations chart given a situation. And this is actually kind of what we've been talking about the last few days. So you have graphed before, but let's please go over some basics. So the vertical axis on the coordinate plane is the y-axis. The horizontal axis on the coordinate plane is the x-axis. Okay, so if this is our coordinate plane, this would be the y, this would be the x. Points are always written like this. You always have an x and you always have a y. The x coordinate shows us how far we are going to the left or the right from 0, 0, also known as the origin. The y coordinate tells us how far we are going up or down from 0, 0. Okay, so let's take a look at some of these, and we're going to label the points and their quadrants. So if we find A is right here. We didn't go left or right any, so that's going to be 0 for x. Remember, x always comes first. And then we went down 5. So because we moved down 5, it's negative 5. This is not in a quadrant, but it's actually on the y-axis. Okay, so let's take a look at B. B is right here. We went 4 to the right, which is a positive 4, and we went down 8, so it's negative 8. If you remember the quadrants, this is 1, 2, 3, 4, moving counterclockwise, and you must use the Roman numeral. So this would be 4. For C, C is located right here. We went 9 to the left, which means negative 9, and we went 3 down, which is negative 3. This falls in the third quadrant, so we would say quadrant 3. Taking a look at D, D we went to the right 1, which is a positive 1, and up 1, which is a positive 1, and this is quadrant 1. E is located right here. We went to the left 7, so that's negative 7, and we went up 4. That is in quadrant 2. And then lastly, F, F is located right here. That one we went to the right 8, which is a positive 8, and we went up 6, positive 6. Okay, this is located again in quadrant 1. So let's kind of imagine where our points would be located. One thing I can tell you is that here's quadrant 1, 2, quadrant 3, and quadrant 4. The symbols of our x and y value are both positive. You have two positive numbers when you end up in quadrant 1. In quadrant 2, your x value is going to be negative and your y value is going to be positive. In quadrant 3, you have two negative values. And in quadrant 4, you're going to have one positive and one negative. So this is going to help us figure out which quadrant each of these points will end up in. So looking at problem 2A, we have a negative number and a positive number. Okay, where would these be located? Which quadrant? So we have to see which one does this match up to. And it matches up to quadrant 2. We would go left 45 and up 100. So this is going to end up in quadrant 2. For part B, we have a positive and a negative. So here you have a positive and a negative in quadrant 4. Okay, again, you would go right 304 and down 4. For C, because we have a 0 here, this means that we have gone nowhere left or right, but only up or down. So when your 0 is in the x spot, then your spot will lie on the y-axis. If you have 0 in the y spot, then you went left or right, but nowhere up or down, so your spot or your point will be on the x-axis. So let's do something a little bit different. Before we located where the points were at on the coordinate plane, now I'm going to give you the point and you have to plot it. So remember, every point gives you an x and a y. We always start at 0, 0 here in the origin. Um, we're going to go to -2, so we're going to go left 2 and then down 6. So this is point G. Okay, and then it also says label their location on the line, um, and we should say what quadrant we're in. Point G ended up in quadrant 3. For H, you have 0, 9. Again, you're going nowhere left or right, and then you go up 9. That's H. Please remember to label your points, because if you just give me a graph with a bunch of points on it, I'm not going to know what is what and if it is right. So please make sure that you are labeling. Okay, this ended up on the y-axis, so we would write y-axis here. For I, you're going to move to the left 5 and nowhere up or down. Okay, and so this ended up on the x-axis. And then for J, you have 4, -9. So we're going to move to the right 4 and down 9. Okay, this is in quadrant 4. Okay, so remember, you always have to move left or right before you move up or down. So let's go back to our roses are red problem. It says roses are red had $20 service fee and was 75 cents per rose. Flower Power had a $60 service fee and was 50 cents per rose. Use the graphs below to help answer the following questions. So I'm going to zoom out just a little bit so we can see these graphs if it'll let me. Okay, so I apologize that it's so small. So on both graphs, the plotted points fall in a line that is blank from left to right. So what's happening to these lines? Are they going up? Or are they going down? Well, if you notice in both graphs, they are going up. Therefore, would we say rising, falling, lower, higher, increasing, or decreasing? Okay, on both graphs, the plotted points fall in a line that is increasing from left to right. The shapes of both graphs show a steady increase in the cost of the roses as the number of roses ordered increases. The roses are red line starts blank, but it's steeper. So the roses are red line starts blank, but is steeper. Okay, so it means that it starts lower, but it's steeper. It goes up faster. Do you see that? It's going up faster because those roses actually are more expensive. So compared to with the flower power graph, this shape means that the service charge for the roses are red is higher, I'm sorry, lower, but the charge per rose is higher. Okay, let me read that again. Compared with the flower power graph, so we're looking at both, this shape means that that the service charge for the roses are red flowers is lower, so the cost they charge you when you walk in is lower, but the charge per rose is higher. So here are those graphs again. Okay, it says the roses are red line intersects the y-axis at the point what? So this is roses are red, and this is flower power. Okay, it intersects the y-axis at this point here. We can say that that is 0, 20. Flower power intersects the y-axis at this point, which that's 0, 60. These data points on the y-axis represent the cost of the blank for each flower company. Okay, cost of the what? What is this? This is the service fee, if I can spell it correctly. Sorry about this. That's the service fee for each flower company. If the soccer team orders 45 roses from Roses Are Red, they will pay about what? So we can approximately guess how much it's going to cost. So 45 roses is about here, which means it'll go about here, right? which is approximately like $54. If you said 53 or 55, that's fine. And then if we did the same thing for flower power, we would say, zoom out just a little bit. 45 roses is about here. We're going to move up along that point, which goes right there, which is about $82. I hope you agree with me. 82, 81. Okay. From roses are red, the soccer team can get about how many roses for 70? So now we're going to go to cost in dollars. Okay. So before I said, I want to know how much the number of roses cost. Now we give you a dollar amount. So we're looking for how many roses we can get for $70. So here's $70. We're going to move across our graph until we hit the line, and then we're going to go down. Okay, so approximately like 66 roses for $70 at Roses Are Red. And if we do the same thing for Flower Power, we're going to get about 20 roses. Okay, because we started at 70, went over to our line, and then went down. One important thing about graphs we haven't discussed is scale. Scale is how much each blank on your graph is worth. Okay? Scale is how much each dash mark on your graph is worth. Each of these dash marks, how much are they worth? Okay? That's what we're going to be looking at. That's scale. Not every mark needs to have a number. So the scale must be the same for the whole axis. Okay? So if you start going up by 2, you can't all of a sudden go up by 5. Okay? If you don't want to start at 0, you could make this. Okay? That's for horizontal, that's for vertical. So it's like a little Z on it, okay? So it says find the scale of the y-axis of each of these graphs, okay? So what is each dash mark going up by, right? We have a blank one, then 4, a blank one, then 8, a blank one, then 12. So I think it's safe to say that each of these dash marks is going up by 2, okay? So our scale of the y-axis is 2. Okay, this one, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So our scale of our y-axis is 1. And then this one, it says blank 8, blank 16. So I think each of these is going up by 4. Okay, the interesting thing about this is the exact same data being graphed, but look at what happens when you change your y-axis. Okay, it changes the representation of the data. Okay, so if you want to manipulate your data, you change your scale. So what we're going to do now is we're going to come up with a multiple representations chart. So we have covered every way to represent data. Okay, so here's our situation. It says Warren Sports Awards is catering Germano's Pizza. Warren pays a $10 fee to place the order with an additional $5 per student attending the award ceremony. Fill in the verbal, numeric, and algebraic and graphical representations below to show the situation. Okay, so we have to figure out what we're doing. So we're hosting this party and we need to come up with our variables. Okay, remember I told you to always look here. This is your independent. This is your dependent. Okay, so our independent variable would be number of students, and our dependent variable would be total cost. So we can say that our dependency statement is the total cost depends on the number of students. Okay, so total cost depends on the number of students that's going to attend the ceremony. So here's our numeric representation. If 50 students come, 100 or 110. How could I figure out the cost? Okay, so to order the pizza, it's a $10 fee plus $5 per student showing up. Okay, if we say this is 50, okay, you're gonna have to bear with me. I don't have my calculator here with me, so I'm gonna have to do this in my head. Oh, who would have ever imagined? Okay, so 5 times 50 is 250 plus 10, so it's going to be $260, right? So if 50 kids come, Warren has to pay $260. So again, there's the $10 fee, $5 per student. Now we have 100 students coming to the banquet. So you have 10 plus 500, or $510 if 100 kids come. Okay, what if 110 students come to the banquet? So we would do 110 times 5, which is 550, plus our $10 order fee, which would be $560. Okay, so do you think we can come up with an algebraic representation based on what we just did? Okay, let's come up with our variables. So we're going to use S and C. C is your total cost. S is going to be number of students. So looking at our numeric, what did we do to come up with our total cost, right? So we said our total cost is equal to our $10 order fee plus $5 per student. Okay, now there's one more way we can represent this, and it's the graphical representation. So the scale of our horizontal axis, so we have to be, this is our independent. Independent always goes on the x-axis, and our dependent always goes on the y. So we would say this is number of students, and this is our total cost. Okay, really important to label. Okay, label axis and give a title. So we will say banquet. Okay. Um, Remember our scale. We said it has to be the same. You have to get all the way up to 110. So I'm just going to go by 10. And then our vertical axis has to get up to 560. So I'm going to go up by 50s. Okay. And did you use a break? I'm going to say no. Okay. Because this is my 0. So I'm going to say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, right? And then my scale, I could do 50, 100. I'm going to spread these out just a little bit, sorry. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550. Okay, so again, if everything's going up by 50, I'm going to skip a line. Okay, and then I plot my points. Now, what points do I plot? You filled out a table. This point here is 50 to 60. You've got to plot that point. 100, 510. 110, 560. Okay, those are the 3 points that we are going to plot. So 50 and then 260. So 50 is here, go up to about 260. I'm going to approximate just a little bit. Okay, and then the next one was 100 and 510. 100, going all the way up to 510, and then 110 and about 560. Okay, one thing that we can recognize is that if they were to place this order, it was a $10 fee to place the order. So if 0 people came, it'd be like $10. So we could start this graph all the way down here. Okay. Okay, I'm going to do one more of these. It says an animal shelter begins a fundraiser having earned $150. Each day that goes by, the shelter raises an additional $20. Fill in the verbal, numeric, algebraic, and graphical representations. Okay, so our independent variable, we have to figure out what we're looking for. Remember, here's our independent, here's our dependent. So our independent variable is number of days, so number of days that have passed. And then our dependent is total donation. So how much are they going to be able to donate? To come up with our dependency statement, you take your dependent variable, so total donation, and that depends on the number of days. Okay, total donation depends on the number of days that have passed. So we started our campaign at $150. Every additional day, $20 is raised. Okay, so after 7 days, we would say that 20 times 7 is 140 plus our original 150. So 290 days or $290 would be donated after 7 days. After 12 days, we would say 12 times 20, which is 240, plus our original 150, $390 would be donated. Now, if we go a whole month, like that 30 days, we would say 30 times 20, that's 600, plus your original 50, $750 was raised. Okay, so let's come up with our algebraic representation. Okay, so let's say T for total donation, and then we will say D for number of days. Okay, so our formula, our function rule would be T equals our original donation of 150 plus $20 per day. Okay, so in order to graph this, we would say this is our total donation, and this is our number of days, and this is our animal shelter donation. Okay, so in order to do this, we have to get 7, 12, and 30. So we have to get up to 30 based on our numeric. So 1, I'm just going to go up by 1. Our vertical, though, we have to get all the way to 750. I'm going to again go by 50s, but I'm going to use a break. Okay, I'm going to show you how that works. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. You are way off. Okay. Um, every line does not have to have a number. I'm going to do every 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This would be 30. Okay. So with my break, this is still 0. Okay. I'm going to draw a break here, and then I'm going to start. My lowest is 290, so I'm going to start at 250. Okay, if you do not show this break, you would have to now go up by 250. Okay, that would be 300. This is 350, 400, 450, 500, 550, 600, 650, 750. And we said we had to get up to 750, so we're going to stop there. Okay, our 3 points, remember, it's your X value and your Y value, 7, 290, 12, 390, and then 30, 750. Okay, so let's plot those 3 points. 7, 290, 5, 6, 7, 290, about there. 12, 390, 10, 11, 12, 390, okay? And then 30, 750. We're going to go all the way out to 30, 750. Notice how if I were to connect these dots, they give me a pretty straight line, okay? I know this was a pretty long video. I hope everything goes well today. You are now to work on worksheet 4, okay? Get this done for me on Monday. I will check it then. Have a great day.